You're welcome to this channel. So today we'll be solving questions on data communication and computer network. So I have these questions over here. So first of all, question 1 says, so it is a section B question and we are required to answer. So in data communication, we will be required to answer only 2 questions. One will be compulsory and you choose one from any other 2. So the first one, or the compulsory part, I have over here. So this is data communication and computer network 2025. So it was written last year. So let's try and solve some questions on it. So over here I have question 1. So question 1A, because my board is small, we'll be taking it little by little. So question 1A, I have describe. So I have described the 7 layers. So the 7 layers of the OSI model and their function. Right? So this is question 1A. So we've already listed the 7 layers. Now we are to give its function, right? So we start with the physical layer. So the physical layer. So let's give it function. So it defines the transmission, physical transmission of raw binary data. So of raw binary data across a physical medium. Across a physical medium like we have the cables, we have signals, etc. So it defines the physical transmission of raw binary data across a physical medium like across a physical medium like the cables and also the networks. Then please do not, so D, we are moving to the data link layer. So the data link layer, it ensures that, so over here we have the data link layer ensures that data is transmitted over a local network segment. So the data link layer ensures that, so let me divide this. So it ensures that data is transmitted over a local network or transmitted across, let me use across a local network segment. Now please do not, so we move to the network layer. So we move to the network layer, right? So what's the function of the network layer? So the function of the network layer is to ensure, it's responsible for routing and addressing networks, or routing and addressing between different networks. So it is responsible for routing and addressing between different network. So it is responsible for routing and addressing between different network. So we have this over here. So we've stated 3. We are left with 4. So let's move on. So we stated the 3. Now 4 will be transport layer. So what will be the function of the transport layer? So the function of the transport layer is to ensure reliable. So is to ensure reliable data transfer. Then also error checks. It checks error. And lastly, we have flow control. So this is the function. So after writing the transport layer, we move to the sausage. That's the section. So section, we move to section layer, right? So section layer, what is the function of the section layer? So it manages, or one, it establishes. So establishes, it manages. So it establishes, it manages, and terminates. So and terminates communication. Sorry. So communication. So sausage pizza. Then we move to presentation. So the presentation, the function of the presentation here is it translates. So it translates data format. It translates data format, right? Then performs encryption and compression. So this is it. So after the presentation layer, we move to the application layer, where it provides network services for end user application, such as email and web browsing. So now let's list the 7 layers of the OSI model. We have the physical layer, we have the data link layer, we have the network layer. So you shouldn't miss them. We have the network layer, then also we have the transport layer, we have the section layer, we have the presentation, and we also have the application layer. So these are the 7 layers of the OSI model. Now let's move to question 1b. So lastly, let's look at the cable tester. So it is used to check the continuity and also check correct wiring. So check continuity. So check continuity and correct wiring. So we are done with question 1b. We are done describing the tools over here. 2. Wire or bad crimping. So bad crimping of the wire. So bad crimping of the wire. So 3. Untwisting the wire. Sorry, so the 2 is connector. So untwisting the wire too much. And 4. Lastly, you have to avoid wires. So to avoid this, wires not pushed correctly into the connector. So these are the 4 mistakes you should avoid: wrong wire color order, bad crimping of the connector, untwisting the wire too much, and wire not pushed correctly into the connector. So now let's move to question 1D. Question 1D says, what is a twisted pair cable and why is it widely used in networking? So twisted pair cable is, it comprises of 2 or more cables that are twisted. And also, why is it widely used in networking? So it is widely used in networking to avoid interference. So if we are to explain this, or if you are, this is just, it was I think 2 marks, so you are not to write anything plenty. So yeah, they are just asking you what a twisted pair cable is and why is it widely used in networking. So I said it is used in web networking to reduce interference. So now let's move to question 1E. So this is question 1E. This is the calculation aspect, right? So let's read the question and let's break it down. So a communication cable has a bandwidth of 5 megahertz and uses 16 discrete signal levels for transmission. Using the Nyquist theorem, calculate the maximum data rate that can be achieved in a cable. So note that we have the Shannon's theorem and we also have the Nyquist theorem, right? So we are asked to use this his formula, the Nyquist theorem, right? So this is how we solve this question. So first of all, we list our terminologies or what is needed. So in a question, the bandwidth was what? So the bandwidth was 5 megahertz. Then also we have the discrete signal. So over here, the discrete signal becomes the what? M. So the M is what? 16. Now the formula, so this is the formula with the Nyquist theorem. So this is the formula. You have C is equal to 2B and log 2 into bracket M, where the C is the maximum channel capacity. We have to B for the bandwidth, we have log 2, and M for the discrete signal, the discrete signal. So we are to solve for this. We have to calculate for the maximum data rate that can be achieved in this cable. So we have this, right? So let's put this in a formula. Now, in megahertz, 1 megahertz is equal to 1 million. So over here, if it's 5 megahertz, we are going to get 5 million. So 6 zeros over here. So let's move on. C is equal to, then we have 2. Then the B was what? Times 5. How many zeros? 6. So times 10 raised to the power 3. Or you can just multiply and just write the 5 million over here. So we have this times what? Log 2 into bracket. The M was what? 16. So this is it. Now, you don't just point this straight on a calculator. We have to solve for this. So we solve for the log. So log, you write log 2 into bracket 16 is equal to, then you write log 10, 16, then divided by log 10, 2, the base 2 over here. So you punch this on your calculator. So you punch log 10. So you're not going to punch log 10 because it's already 10. So log, then into bracket, you punch 16. So you are going to get, when you punch this, you are going to get, at the upper part, you're going to get 1.2041. Let's end it there, over. Now let's punch log 2. So log 10, 2. So you are going to get 0.313010. Now, after this, you divide it. So into bracket, on the top you have 1.2041. Then the denominator we have 0.3010. So you are going to get 4.000. So just let's make it, or let's make it 4. Yes, just 4. So this is 4. The whole of this, we've solved for the whole of this. So this is 4. So once we are done, let me clean the top side. So we have it to be 4, right? So once you are done, you put this in a formula. So C is equal to then 2 times 5 times 10 raised to the power 6. So this is equal to the 5 megahertz. That's the one. This is 1 million. So 5 times 1 million, you are going to get 5 million. So times then the 4. That was the log like this. So we solved for this, and our final answer was 4. So over here, you write 4 here. So you're going to write 4. So you punch this straight on a calculator. So 2 times 5 times 10 raised to the power 6 times 4. You are going to get 40,000. So 40 million, sorry. So 40 million. Now we are not done. When you get your final answer, you divide it by 1 million. So 1 million. So we divide 3 zeros by 3 zeros, 3 zeros by 3 zeros. Now our final answer is 40 Mbps. So this is our final answer for question 1E. So the maximum data rate that can be achieved in this cable is 40 Mbps. So we are done solving for question 1 for all. So this goes for, let me see, 10, 11, so 15 marks. Question 1 for 15 marks, and that was the compulsory part. So we are done solving the question 1. So we move to question 2.